Okay, fine. Thank you very much. I will be talking about some important issues on railway safety. First thing is about history of railway safety. History of railways is about 2 centuries old, and so is the history of accidents. The picture you are seeing on your screen is about the inaugural run of intercity trains between Manchester and Liverpool on 15 September 1830. This was the first train in the world which ran between two cities, and it met with an accident. So accidents are part of all modes of transport. Our endeavor is always to minimize the risk. What is risk? We will see. Risk is a combination of severity of an accident and probability of accident. So we will see some important issues on safety. That is, first thing is, what is safety? We will try to define safety. Can we quantify safety? Well, why do we need to quantify it? Unless we quantify, we don't know where we are and where we have to go. Have we improved? So to measure all these things, it is important to measure safety. As Dr. Chaturvedi in the previous session said, we have to quantify quality. Similarly, safety has been quantified, and we will later on see that it has been quantified into 4 levels universally for all modes of transports, whether it is road vehicle, whether it is aerospace, or whether it is railways. This is safety integrity level 1, 2, 3, 4. And the level of safety is decided based on the severity of consequence of accident. Next question is, can we achieve 100% safety? Well, answer is no. There is some accepted level of risk which has to be taken by depending on the society. Every society, every country has its own minimum accepted level of risk, and safety is only an insurance that you will not have more than the small amount of risk that you have already accepted. Well, if 100% safety is not possible, then how we can determine what is the amount of safety we need for a function? For example, in the railways, there are different functions like signal clearance, giving command to the uh, interlocking system, and so on. For this, our safety standard Senelec provides a guidelines to decide what level of safety is required for what level or which function. We will see about Senelec later. Then, having determined the safety level, how do we go about achieving it? In other words, how do we design different subsystems and put in and operating procedures to be put in to achieve the required level of safety? Again, Senelec comes to rescue, and Senelec is the universally accepted, well, not universally, but at least in India and Europe, Senelec is the Bible for railway safety. So Senelec uh, gives the guidelines to decide how to achieve a given safety level. And having achieved the safety level, we have to show to the customer or to the public in large that we have achieved this safety level. So Senelec provides the guidelines how to achieve and how to demonstrate the safety level. Uh, so issue number 1, we will see what is safety. Safety has been defined in Senelec in just a few words: freedom from unacceptable risk related to human or environment. Now, there is a key word here. This is unacceptable. That means, as we discussed earlier, some amount of risk has already been accepted by the society. And when we talk of safety, we only make sure that we don't increase the risk beyond what is already accepted by the society. And we have seen earlier that risk is the combined effect of severity of hazard or accident and probability of the hazard. Well, hazard is a technical term. Hazard is a situation where there is a possibility of an accident. So let's say in plain words that risk is the combined effect of severity of an accident and probability of an accident. If the if the severity is very huge, then we have to reduce the probability of that accident to the acceptable level. We have talked about Senelec. Here, I would like to spend a few minutes on Senelec because this is very important for the railway engineers. Senelec has got 4 standards. The first is EN 50126. This is for railway applications. This is for complete railway domain, whether it is signaling, whether it is rolling stock or track. 50126 applies to the complete railway application. It has got part 1, which defines the RAMS process. So this is not only for safety, this is for reliability, availability, maintainability, and safety. And part 2 deals with particularly with safety. So these 2 parts, they are applicable to the complete railway domain. Then there is another standard, that is 50126 part 3, which is a guide to the application of 50126 to rolling stock RAMs. This applies only to the rolling stock domains. Apart from this, there are 3 standards which apply to signaling systems. 50129 particularly provides the guidance for electronics hardware as well as the system. I have seen 50129 being applied to rolling stock also. So people have started using this for rolling stock also. Then next standard is 50128, which is again for signaling system, but for software for signaling system. And the last one is 50159, again for signaling system, but for safety related communication. As you will be aware that metro trains, they run mostly on Wi-Fi and maybe on Tetra also at some places. But the communication system as it is cannot be used to control the safety functions. So a safety layer is built up over and above the communication packets, and how these safety layers are to be put, that is described in 50159. Then we come to the acceptable level of risk. We have talked that every society has got its own acceptable level of risk. It has decided, and the risk should not be higher than this acceptable level. There are various methods for various countries they have applied. Generally, the most popular one is as low as reasonably practicable, ALARP method. This is a very popular method, and in India also we are following this method. We will see how this method is applied. Here also kindly see the key word, that is reasonably practicable. Again, the risk is not to be reduced to 0. We need to reduce it to the reasonably practicable level, which is acceptable to the general public. Uh, Next issue is safety quantification. I mentioned that safety has been quantified into 4 levels. These are level 1, 2, 3, 4, highest being the level 4. So for any hazard or any accident, we look at what is the severity of most possible severity of the accident. Maybe head-on collision. For example, suppose there is a hazard in which conflicting signals have been cleared for two trains. There may be head-on collision, there may be side collision, or there may not be any collision at all if there is no train. So we look at the highest possible severity, and that is head-on collision. Since this cannot be accepted, its probability has to be brought down to a very low level, and that is given in the Senelec as less than 10 to the power minus 8 per hour, which is about 1 in 10,000 years. So similarly, for other things, for example, doors of a metro train open in the moving train is is a is a is not a good thing. I mean, it is not acceptable, but it is not as severe. The consequence is not as severe as the other one. Probably this is assigned a safety level number 3 or 2. This is a subjective matter, and the probability of its occurrence is reduced to less than 10 to the power minus 7 or minus 6, and so on. This way, for every function of the railway, we assign a safety level, and then we reduce the probability to a uh, to the prescribed level. Apart from this quantitative probability, Senelec also suggests, or not suggests, it requires, mandates certain qualitative measures to be taken. For example, for highest level of safety, SIL 4, uh, uh, it gives for any software which is controlling a SIL 4 function should not use online memory allocation, or should not use nested pointers, and so on. So there are similarly, there are for hardware also, there are certain guidelines available. Well, issue 3 we discussed was, is 100% safety possible? This has already been answered. No, 100% safety is not possible. Some minimum amount of risk that has already been accepted, and we can bring down the risk to that much amount. The next issue is, how can we determine the minimum level of safety required? Well, we have seen some methods of determining the minimum level of safety, and one of them was LR that we have already seen, which can be applied for determining the safety level. Now we come to how to achieve the required level of safety. Again, Senelec has got such guidelines. If you follow those guidelines, you will achieve safety integrity level. For example, for products, it has given a quantitative requirement, which we saw for SIL 4, it was 10 to the power minus 8 per hour. We have to bring the probability of such failures to less than this. And there are some qualitative requirements. An example of metro rail, the safety is allocated to different subsystems, for example, signaling, rolling stock, etc. And each subsystem is required to demonstrate that the required safety level has been achieved. Then the last issue was, how do we demonstrate that the required safety level has been achieved? Well, all documents have to be prepared. You have to give a justification. You have to calculate and show that you have achieved this. Probability of failure has been reduced to 10 to the power minus 8 per hour for SIL 4, and maybe minus 10 10 to the power minus 7 for cell 3, and so on. Documentary proof for uh, quantitative requirements as well as for qualitative requirements, that you have is followed all the guidelines, that, for example, safety audit has been performed, that your design engineers are well qualified, etc. Giving all these things, a safety case is prepared and put up to a independent safety assessor who assesses everything and then certifies the system to be safe at the required level. So these are all the 6 issues which I wanted to touch upon. And concluding my lecture, I would like to say that we have uh, that Senelec is the Bible which guides us in determining what is the minimum safety level is required, how these levels are to be achieved, and how do we justify that this safety level has been achieved. And the level is normally decided or determined by methods like LR. Thank you.
Thank you very much, sir. So we got some insights on safety also, and we look forward for